Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 2, 2.5, and questions that involve circumcircles. What exactly is a circumcircle? Well, if you have a triangle, any triangle, it's possible to draw a circle which goes through each of the triangle's vertices. So if you have a triangle, it's possible to draw a circle that will go through each vertex of that triangle. And the circle that you get is called the circumcircle of the triangle. Now, in the last lesson, we learned that the perpendicular bisector of a chord passes through the center of a circle. We can use that property when we have questions on circumcircles. So if we calculate the equations of the perpendicular bisectors of any two sides of the triangle, where those two lines meet will give us the coordinates of the circle's center. Now let's have a look at how that works out in practice. So example 1, given a triangle with those three vertices, first of all find the coordinates of the center of the circumcircle of the triangle, and then find the equation of the circle. I'll talk you through the idea, because there's quite a lot of steps in this, and then I'll let you have a go at working through the example yourself. So first of all, we'll do a sketch. That's the triangle, that's its circumcircle. Now I want to find the coordinates of the center. That means I'm going to have to draw two perpendicular bisectors. I'll do the perpendicular bisector of PQ, because I know that goes through the center, and the perpendicular bisector of PR, because I know that goes through the center. I could have used QR as well if I wanted to. It doesn't matter which two sides you choose. Where those two lines meet, that'll give me the center of the circle. To find the equations of those two lines, I'll do it in the form y equals mx plus c. So first of all, you need to find the gradient of each line. I'll do that by finding the gradients of these two sides, PQ and PR, and then doing -1 divided by those gradients, because the lines I want are at right angles to those. That'll give me n, and then last of all, I'll need to find c in y equals mx plus c. That means I need to know a point on the line. Well, the easiest point to find is these midpoints of PQ and PR. So I'll find the midpoints, substitute them into y equals mx plus c. That'll give me the two lines, solve them simultaneously, that'll give me the center. And then to find the equation of the circle in part 2, I need to know the center, but I found that in part 1, and I need to know the radius. To find the radius, I'll find the distance from the center to any of these three vertices. Doesn't matter which you choose. Okay, I'll let you see if you can make sense of all of that. So pause the video, have a go at working through this yourself, and then come back to me when you're ready. Okay, let's have a look. So that's the question. I'm going to find the equation of the line that goes through M1 and C. Well, that line has the equation y equals mx plus c. As always, I'll find the gradient first, m. Well, to find the gradient, I'll find the gradient of PQ, which is the difference between the y values and the x values. That gives me the gradient of PQ is equal to -1. The gradient of the line that I want through M1 and C is at right angles to that, so I'll do -1 divided by -1, which gives me a gradient of 1. Going back to y equals mx plus c, I now know what m is 1, so the equation of the line through M1 and C is y equals 1x plus c. To find c, I need to know a point on the line. The easiest point to find is M1, the midpoint of PQ. So that's the average of the x values and the average of the y values, which gives me 1810 for M1. Substituting that point into y equals x plus c gives me 10 equals 18 plus c, which means c equals -8. And the equation of the line through M1 and C must be y equals x minus 8. I now do exactly the same thing to find the equation of the line through M2 and C. So again, the equation of the line will be y equals mx plus c. To find the gradient, I find the gradient of PR. The difference in the y values over the difference in the x values is that, which simplifies to -1/2. The gradient of the line through M2 and C, it's at right angles to that, so I do -1 divided by -1/2, which means the gradient of the line through M2 and C is 2. That I can substitute into the equation of the line, y equals mx plus c, which gives me y equals 2x plus c. To find c, I need to know the coordinates of a point on the line. That'll be M2 this time. That's the average of the x coordinates and the average of the y coordinates, which gives me 1812 for M2. And I then substitute that into the line y equals 2x plus c, which gives me 12 equals 2 times 18 plus c, and c equals minus 24. So the equation of the line through M2 and c is y equals 2x minus 24. Okay, what have we done so far? Well, we found the equations of these two perpendicular bisectors. Where they meet, that will give me the center of the circle. To find where they meet, we solve the two equations simultaneously. Well, y equals x minus 8 and y equals 2x minus 24. The easiest way to solve them simultaneously is to say 2x minus 24 must equal x minus 8, because both of those things equal y. That gives us x equals 16. We substitute that into the easiest of the two equations, y equals x minus 8, and that gives me y is 16 minus 8, which is 8. So I now know the coordinates of the center of the circumcircle, and they are 16, 8. That's part 1. Part 2 asks me to find the equation of the circle. Well, the standard form for the equation of a circle is x minus a squared plus y minus b squared equals r squared, where a and b are the coordinates of the center of the circle. So I know those. A is 16, b is 8. I still need to find r, the radius of the circle. Well, that's the distance from C to any of these three coordinates, any of these three vertices. I'm going to choose to use CR, so the distance from C to the vertex R. Using Pythagoras, that's the square root of the difference in the x values squared plus the difference in the y values squared. That simplifies to the square root of 6 squared plus 2 squared. That simplifies to root 40 for R. So the equation of the circle is x minus a squared, that's x minus 16 squared, plus y minus b squared, that's y minus 8 squared, is equal to r squared. Well, r is root 40, so r squared will be 40. Okay, a special case of a triangle with its circumcircle is when the triangle is a right-angled triangle. So if we have something like that, a right-angled triangle and its circumcircle, certain things just to remember if you have a question like this. First of all, the hypotenuse of the triangle, that will be the diameter of the circle, which means that the midpoint of the hypotenuse is the center of the circle. A lot easier to find than in the last example. The angle opposite the hypotenuse is a right angle, which comes from the circle rule, aside from just having a right angle triangle anyway. And useful to remember that that means we can use Pythagoras and say, if pq squared plus qr squared equals pr squared, so if that is true, I must have a right angled triangle. Okay, let's have a look at an example that uses that idea. So example 2, we're given the three vertices of a triangle. We're asked to prove that QR is the diameter of the circumcircle of the triangle, and hence to find the equation of the circle. What's that saying? We'll do a sketch as always. So we've got a triangle. We don't know that it's a right angle triangle. We haven't been told that. But we've been asked to prove that QR is the diameter of the circumcircle. Well, if QR is the diameter of the circumcircle, this has to be a right angle triangle. Or if this is a right angle triangle, QR has to be the diameter. So what we're trying to do is prove that triangle PQR is a right angled triangle. Now, there are various ways of doing that. The method I'm going to use is to show that if I find PQ squared and I add PR squared, I do get QR squared. That is only true when we have a right angled triangle. So that'll get us through the first part of the question. And then the second part is finding the equation of the circle, which means I'll need to find the midpoint of QR to find the center of the circle, and then I'll need to find the radius. Okay, I'll let you have a go at doing all of that. So pause the video, have a go at this, and then come back to me when you're ready. Okay, let's have a look. So that's the question. We've been asked to prove that QR is the diameter of the circumcircle. And the way we're going to do that is by proving that triangle PQR is a right-angled triangle. The way we're going to prove that triangle PQR is right-angled is by showing that PQ squared plus PR squared equals QR squared, because that is only true when we have a right-angled triangle. So first of all, PQ squared will equal the difference in the x value squared plus the difference in the y value squared. So that's minus 2 minus 4 squared plus 12 minus 14 squared. Because I'm squaring it, I don't need to worry about the square root. That gives me minus 6 squared plus minus 2 squared, which is 36 plus 4, which is 40. So PQ squared is 40. Same thing for PR, the difference in the x value squared plus the difference in the y value squared, which simplifies to 160. And then last of all, we'll do QR. The difference in the x value squared plus the difference in the y value squared is that, which gives me 10 squared plus minus 10 squared, which is 200. Okay, what have we done? We found out that PQ squared is 40, we found out that PR squared is 160, and we found out that QR squared is 200. But if I add PQ squared to PR squared, I get 160 plus 40, which is 200, which is the same as QR squared. Now that only happens when we have a right-angled triangle. Pythagoras' theorem only works for right-angled triangles. Therefore, PQR is a right-angled triangle with hypotenuse QR. Therefore, QR is the diameter of the circumcircle of the triangle. That's the first part of the question done. Now we're also asked to find the equation of the circle. Well, the standard form for the equation of a circle is x minus a squared plus y minus b squared is r squared. I need to find a and b. Well, that's the center of the circle, which is the midpoint of QR, because we've said that QR is a diameter. That's the average of the x values, the average of the y values, which gives me 3, 7 for the center of the circle. Now, I also want to find the radius of the circle. Well, CR is the radius of the circle. So if I use the center of the circle and find the distance to R, that'll give me the square root of 8 minus 3 squared plus 2 minus 7 squared, which simplifies to root 50 for the radius of the circle. Therefore, the equation of the circle is x minus a squared, which is x minus 3 squared, plus y minus b squared, which is y minus 7 squared, is equal to r squared. Root 50 squared is 50. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 43 and have a go at exercise 2F. Thank you very much for listening, and cheerio.